Welcome back to Game Developer Unity. Ever noticed how games with tons of objects like bullets, enemies, or missiles stay smooth and lag-free? The trick is object pooling. In this video, I'll show you how to implement object pooling in Unity using a bullet launcher example. By the end, you'll be ready to optimize your games like a pro. Let's get started. What is object pooling? Object pooling is a method where we reuse objects instead of creating and destroying them repeatedly. This saves memory and keeps your game running smoothly. Imagine a bullet launcher firing dozens of bullets. Without object pooling, Unity would constantly create and destroy bullets, causing performance issues. Instead, with object pooling, we pre-create a set number of bullets and reuse them. Let's jump into Unity to see how to build this step by step. Example: I've set up a launcher that fires bullets continuously, and we'll use object pooling to ensure smooth performance. For this demonstration, I've utilized free assets from the Unity Asset Store. Let's dive in. First, in the hierarchy, we have a game object named Bullet Pool with a script attached, also named Bullet Pool. Let's open it up and understand how it works. This script manages the pool of objects. Instead of repeatedly creating and destroying bullets during gameplay, we instantiate them once and reuse them. This approach reduces performance overhead by minimizing memory allocation and ensuring smoother gameplay. Here's how it's done. First, we have public variable named bullet prefab. This holds the bullet prefab we'll instantiate. Next, we have pool size, specifies the number of bullets to create in advance. In this example, we've set it to 10. Also, we've declared a list to store the instantiated bullets. In the start function, we have if a loop iterates up to pool size, 10 in our case, instantiates the bullets, deactivates them to prevent rendering or interactions in the game world, and adds them to the list. This way, we have a pool of bullets ready for use. The main method here is getPooledObject. This method checks for any inactive bullets in the pool. If it finds one, it returns that object for reuse. If all bullets are active, it returns null. This script ensures bullets are reused efficiently, reducing unnecessary memory usage and improving performance. Next, we have the bullet prefab, which includes a rigid body component and a script named bullet. Let's look at what the script does. We have a public variable named effectExplosion that holds a particle system that instantiates when the bullet hits an object. It has only one method called onCollisionEnter that will execute when the bullet collides with another object. It will also make its velocity to 0 and deactivate the game object and generate the explosion effect. This simple setup ensures the bullet behaves realistically, deactivates properly to avoid unnecessary interactions, and resets itself for reuse, contributing to better gameplay performance and user experience. Now, let's talk about the bullet launcher game object. It has a script called Bullet Launcher and a child object named Bullet FirePoint, which is the firing point for the bullets. Let's understand this script Bullet Launcher. It has a public variable named Bullet Pool which holds a reference to the Bullet Pool script. Bullet FirePoint transform specifies where the bullets will spawn. There is also another variable named FireFX that will play the particle system that will play when the launcher shoots the bullet. Now let's understand the shooting code we have done in the update function. As you can see, we have used input, getKeyDown, keycode, space. It means when I hit the space key on the keyboard, the line inside those curly brackets code will execute. The getPooledObject function from the bullet pool script is called to fetch an inactive bullet, if there are any inactive bullets available for use. It loops through the pool and checks if an object is not active in the hierarchy. If it finds one, it returns that object, ready to be used again. If a bullet is available, we set its position and rotation to the bullet firepoint, activate it, and apply a forward force using its rigid body component to shoot it. This ensures that only inactive bullets are reused for firing, maintaining efficiency. Finally, let's see how to assign objects and test the setup. In the bullet pool game object, assign the bullet prefab to bullet prefab. Set the pool size to 10. In the Bullet Launcher game object, assign the Bullet Pool game object to Bullet Pool. Assign the Bullet Firepoint transform. When we hit play, Unity instantiates 10 bullets, all of which are deactivated initially. As we press the space key, bullets are fired from the launcher, deactivated upon collision, and reused efficiently. This is how object pooling works, reusing game objects instead of constantly creating and destroying them. And there you have it. We've implemented object pooling in Unity using a bullet shooting example. By reusing game objects, you can optimize your game's performance and minimize memory usage. This technique keeps your games optimized and running smoothly, even with lots of objects. If you found this tutorial helpful, don't forget to like, subscribe to Game Developer Unity, and leave a comment with your thoughts or questions. Until next time, happy game developing.